Hey, welcome back to the channel. Got a little something on the bench for you here. So we have our super duper mega ultralight 138G 4S 5-incher V2.2. So this is the last installment of the pre-build series, and so we already did the frame. We did all the little pieces and parts modifications. We did our VTX, why we did it, what we did. All that's taken care of. We did our video on the pigtail, so putting the capacitor on the pigtail, getting that ready to go with our XT30, so that's out of the way. We did our beeper and how to solder that up and make it nice and tight and fit, and we did our receiver. So we have our receiver ready to go in. So all these segments are finished, and the next up is our flight controller. What do we want to do prior to the build? What is it that we want to check? And that's what this video is about. Alright, so we got our flight controller all-in-one ready to go. This is the HGLRC Zeus all-in-one 3 to 6S F722. So pretty fast processor, 25 amp with a 30 amp boost. That's per 4 channels, so times 4. BioHeli 32 ESCs. That's something I kind of prefer. So chose it over top of this Beta FPV piece of garbage that I'm gonna have a friend of mine look at a little bit closer. Have voltage going through the OSD, so if you didn't want to black out your camera while you're flying, then you would have to eliminate the OSD completely, and I don't want to get into that, but that's why this came out of the V1. If you're following along at the channel, you know that I did like a prototype and then a version 1, and then like I think 2 more. I rewired it 2 more times. This board gave me all kinds of fits, so that's why I went with the HGLRC, and so far it has been perfect, so no issues. So here's our second one. So we'll go ahead and open this up, go through a couple things. Nice little stickers. Did I say something about stickers? Anyway, so we got the flight controller all in one here in the little foamy block. The other thing is, on the back side of that is a capacitor. I'll put that in stock. We didn't use it. You may want to use this instead of purchasing a separate one. So you do get one you could put on your pigtail, okay? And also, don't forget we have the little 100 microfarad on our VTX. So the capacitance of these two, or these two, would be plenty, no problem, okay? So no worries there. But for me, I'll put that in stock. And then little pigtail. So if you didn't get one with your frame, or you aren't using that one, you can use this one because you like the black better. I don't know. And then we have some gummies, so we can put those in the flight controller to keep the vibrations coming into our gyro at a minimum. You do want these snug, but not too tight. So that's something to keep in mind. And then of course instructions. Actually their manual's not too bad. It's full color brochure. So this side, let's open this up. So if you can read this language, then this side's for you. For me, I'm gonna refold it this way. Okay. So this is the language I read, and like you can see here that it's all broke out. I like that. They've done this. I think more of them are doing it now because of complaints over the years, but finally, you get a full breakout, pin breakout. This is the VTX that we're going with, so it's going to be real simple. We already prepped everything. We're going with the RxSR, so we can just go right off the map here. The only thing that's odd for me looking at this is they're only using the S-Bus. They're not using the SmartPort telemetry, which we are going to use. I want that SmartPort telemetry to come back to me, so that's kind of something I thought was odd. Version 2, this one right here that I love so much, is supporting an XM Plus. This XM Plus that I put on that one came off of a Tiny Whoop Rex 80 quadcopter, and it's super sensitive. If I get real close to real close to me, it would RX loss because it was just so sensitive, which made it a really good receiver for long range or farther away. I mean, I can fly quite a ways and still be over 80% RSSI. So it's kind of interesting on this one that doesn't show the SmartPort telemetry being connected to the T pad on this, but we'll see how that goes when we get a little further along. Other than that, I mean, there's really nothing to go over in here. I mean, me personally, I could spend all day just kind of going through all the things, but I did want to just kind of share a couple little things that I thought was interesting about this flight controller. I don't want to necessarily, sell this thing because, as you know, I don't have any affiliations and no one sends me free anything. So, with this, has the 10 volt and 5 volt BEC. Okay, but I want you to keep in mind with the digital stuff that runs off a 10 volt BEC, it's at 1 amp. So you have a 5 volt rail and they've put 2 bucks on it to make it 10 volt. So if you double your voltage, you're going to cut your amperage in half. It's just Ohm's law. Look that up if you need, but 10 volt at 1 amp. You might want to watch how much stuff you put together on here. You may be close to or exceeding that. I'm going to use the 5 volt rail, and I know that none of my peripherals are going to exceed 2 amps. I'm going to be like at 1.2, maybe at the most 1.2 amps. So I know that just from history, but keep in mind that you want to look into that and measure your stuff. So no black box, which is not a big deal. We're not too worried about that. 5 UARTs, that's really cool, because there's a lot of junk on the market that only has 2 UARTs, and for a 5-inch something this fast, I want a little bit more UARTs, or I might want a soft serial stuff later. I'm not really sure. I might want to have like a switch for an HD camera, like if I want to mount like a peanut on the top or something, and I want to use a UART to turn it on and off, or another UART to activate it and to stop and start filming, all that kind of stuff. It's nice to have those UARTs available. Most of the time, I don't remember on this piece of garbage if it was just 2. I think it was just 2 on this piece of garbage. I'm not real sure. This Beta FPV. Anyway, ESC firmware is Bielhelly 32. So this is a 32-bit ESC, which I prefer. I like the smoothness, the abilities that it has, and also the startup tones. And there's 30 amp boost for 10 seconds, which is pretty good. No current sensing, which I don't really care because I've never really had any luck with that anyway. So yeah, pretty good manual, and the specs and techs and stuff on this is pretty good. So just kind of want to go through all that stuff. Now let's the flight controller and what we're going to do with this pre-build. So let me go ahead and zoom in for you. All right, so pre-build, there's a few things that we want to do to our flight controller before putting in the quadcopter. I kind of recommend, first of all, getting rid of that tin foil on your processor. No thanks. And we're just going to go through a couple things on this to ensure that it's ready to go into our build. For me, I like to do a couple of steps, a few things. It's kind of a few things that we need to do. I like to do it because if you solder this all up, put it in your build and have issues, then the manufacturer or vendor wants to give you a bunch of hoo-ha. So first thing I'm going to do is get this propped up for you here. See that screen? We'll go over here. We're going to do a continuity check. Very first thing I do. Because I tell you what, if for whatever reason, you see that screen? All right. If you have that during this, then it's done. So go ahead and let me get the right leads in the right hands. Your positive and your negative, okay? We're just going to take our pins. We're going to push them into the pad a little bit. And you notice there's no, if that happens, then you're done. don't even bother. Put it back in the package and tell them you need a new one because this one failed. I've just had so much quality control issues over the years with manufacturers. This is kind of a mandatory thing that I go through on any component that I get. So put that on positive, negative pad, and then also I'll go around on the rail. So it's nice to have a little cheat sheet, you know, just have a little something off to the side so you can look in here and go, okay, I know this is, you know, let me put it over here. So I have my positive lead on the negative pad, and then I'll go to this negative pad, that negative pad. I'll go to the positive pads. Okay, 5 and 10 volt, nothing. Negative pads, good to go. The barrel for the USB is good to go. Ground are voltage pads, so you don't want anything happening there. And then also over here we have ground, and then we have our 5 volt pad, so that's good, it's not beeping. And then we go to our ground pad here, so that's good. Okay, and then right here is a 5 volt pad, no beeping, so that's good. The other thing I want to do is ground to the motor pads. So I'm just going to go around all the motor pads. If one of these chime off or beep continuity, then it's bad voltage from the LiPo, and they shouldn't chime off. They should be going through MOSFETs. So if you have a ball of solder somewhere causing one of these motor pads to go, then you go ahead and solder this up, build your quadcopter, get it on the floor, and then it wants to flip out or even fry one of your ESCs, because there's 4 ESCs built into this thing. There's a lot going on in here. So we're good to go. I'm satisfied. I'm happy with that. Now, what I like to do next is hook it up to the computer. So let's go ahead and get the cord. We'll get our cord. We'll plug this into our flight controller. I think the continuity check is pretty important because I like my computer and I like the USB port on my computer. So I like to not have any shorts from here going to my computer. So let's go ahead and hook it up. Alright, so we're over here on the computer. We'll go ahead and plug it in. You can see here we have our solid red LED and a blue blinking LED. Okay, so we have power going to our flight controller. And on the computer here, you can see before we connect, your COM port opened. So that means it's communicating with the flight controller. So we'll go here to setup screen and let's observe the movement on our screen here. Okay, as we move the flight controller, we have movement on the computer. Okay. Now, if you look at your flight controller, it's extremely hard to see on this one. It's kind of it's like a Where's Waldo, seek and find. But right here is a screen printed arrow pointing to this standoff position. So this is actually the front of the quadcopter, and this is the back of the quadcopter. So right, left, back, and front, according to the arrow. So that's important when we first plug it in, because what I want to do is, I'm going to have to take this off camera to do it, but I want to try to explain this best I can. Like, this is your computer, so if you're using a desktop, this is your PC. Not your screen, but your PC. If you're using a laptop, obviously your screen and PC are one piece. But you want the front of your board to line up directly perpendicular with your PC. So let's just, okay, so it'll be like this. So that screen arrow is pointing that way. Make sure you're perpendicular. And hold this as level as you can, okay? That's what I'm doing right now, is just level and as straight as I can with the PC, okay? And then we're going to come up here and we're going to do reset Z-axis. Oops, let me do that again. You can do this as many times as you need, but so now we're nice and level. So pitch forward, pitch back, right, left. Now you see how fluid this is? If I just kind of, let me show you over here. See how I'm kind of rotating this. As I move this around, it moves on the screen exactly the same. If you're getting it like a lot of stuttering and it's not showing up smoothly on the screen, then you can come over here to calibrate accelerometer, and just try to get it as close as you can, you know, just as level as can be. You know, we're not real technical at this point. Once we do in the quadcopter, we'll want to make sure that it's level as can be. But right here, just hold it as level as you can, and then calibrate your accelerometer. And if it still is like, you know, if you're moving it around like this, nice and fast and all that, and it's not keeping up, like let's say on the screen, it's going like tick, 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 tick. But in your hand, you're doing this, then there might be something wrong with your gyro or accelerometer. They're all one piece, so that's not a good thing. Send it back. So we're good to go here. You can see that it's nice and fluid, and then if I hold the screen printed arrow directly at the camera or at the computer, I reset that and then pitch back, forward, right, left. It's just no problems. So that's all we needed to know about that. Let me jump down a little further. We'll explain all this stuff in the configuration. We'll go through all the settings and everything that we're going to do. So we're not really worried about any of this stuff until the build. And the one thing we want to do while we're in here, besides checking here to make sure our gyro and our accelerometer is correct, is we just want to check the version. So go ahead and type in version and hit enter. And then here we have, you can see that we're 4.2.0 version. So that'll work, because all the work that I've done on the previous build is in that same 4.2. So, and then the last thing to do in here is just type in DUMP, hit enter. Now you're going to grab all this information, okay? So just grab all the way up here and go to dump right there, and then go ahead and copy to your clipboard and paste this into a note file. Have this on hand, so if anything happens during the build, or you tick things, you're not sure what you did, you need to get it back to where it was, you know, you can use this file. That's it for the computer. All right, so everything's done. I'm just gonna give it, my hands really dry. Just want to make sure nothing on here is like super ridiculously hot. It shouldn't be. These little bucks right here, sometimes they can get, there's two of them right here, they can get really hot. And if they're bad, sometimes they'll get really hot. Like they'll actually burn your finger. So be careful. No, everything's good. I'm happy. We disconnected from Betaflight so we can unplug our flight controller. And that's a good flight controller in my book. And right now, I mean, to be honest with you, this is when you want to know whether or not this is good or not. You know, if this is bad, you can send it back right now and have no issues from them. Like, oh, you soldered it, or you burnt it, or, you know, you're not, you know, going to get a refund, or you're not going to get another one because of whatever reason they want to make up. So we're good to go here. Let me see. Just want to go through a couple texts and specs with this. So let me zoom in just a little bit more. All right, so we have here just real quick a little bit of a layout. We'll go through these pads during the build. The things that we're going to solder up, we'll pre-tin the pads that we're going to use. And then I just wanted to kind of go through here. We have like the boot button. If you needed to do a different firmware or update or do something, then this is the button you'll hold down when you plug it in and do a firmware update or whatever you want to do. And here's that pesky little arrow that I was talking about to point to the front of the quadcopter. So here's your gyro. Right here is your accelerometer and your gyro. This is your MPU 6000 chip. So if you see on your computer that it's not turning or twisting, or it's not acting properly in your setup screen, and you look at this chip and you might see solder ball on the edge of it, or the chip isn't soldered completely, or it's cracked or damaged, that's why, and that's a good indication. You can tell the manufacturer vendor. Your OSD chip, so OSD information has overlaid your video by this chip, so if you have any issues, you can kind of look to see things that might be going wrong physically with that. And then of course here's our F7 processor, so your MCU. But that's about it. I think that's let me zoom out for you. Like I said, during the build video, we'll go through all the points and pieces. We'll get our diagram. We'll kind of make sure that we know where to go and how to hook it up. We'll get all of our pieces and parts to put it all together and get it up and running. I think I'm going to try to figure out a way to I'm going to try to give you my dump file. I'm going to try to give you the dump file here. So that way, I mean, I have spent a lot of time tuning to keep my motors cool. Of course, you may be using different motors on yours. They don't offer these anymore for some reason, which really aggravates me. I've tried to talk to Diatone to figure out who it is that was making them, whether or not we could get them, things of that nature, but that's out the window as far as I know. But anyway, I'll try to figure out how to get that dump file put on so you can just copy and paste it in, and you can go with those settings. So yeah, the next video will be putting it all together. So hopefully this was informative to you. Hopefully you might have caught a problem before your build and you can get it resolved. But yeah, hey, I appreciate your time, and if this video was helpful to you, give a thumbs up and subscribe if you hated it. Man, you give me a thumbs down, it all works. Enjoy the breeze.